Who's a good puppy? Who's a good puppy? Who's a good puppy? So Trix, you know what I'm getting ready to teach my students today? Can I practice on you? So, you know what I'm going to teach them today? Linear motion! Hey, did you know that linear motion is relative? What happens is that when we describe the motion of an object with respect to another object, we say that the object is moving relative to the other object. So, for example, if you have a book at rest relative to the table it lies on, and it's moving about 30 kilometers per second relative to the sun. Did you know that? Oh, no, you didn't know that. Please don't lick me in the mouth. So what happens is the book moves even faster relative to our galaxy. When we discuss the motion of something, we describe its motion relative to something else. An object is considered moving if its position relative to a fixed point is changing. So for example, if we say that a space shuttle moves 8 kilometers per second, we mean its movement relative to the Earth below. So when we discuss the speeds of things in our environment, we mean the speed with respect to the surface of the Earth, even though the Earth moves around the sun. But here's what I want you to think about, Trix. So let's say that there's a hungry mosquito and it sees you resting in a hammock over at the campground with me in a 3 meter per second breeze. How fast and in what direction should the mosquito fly in order above you to eat you for lunch? So if you think about it, the mosquito should fly towards you into the breeze. When above you, it should fly, well, about 3 meters per second in order to hover at rest above you. Then it must continue to fly at 3 meters per second to keep from being blown off. Or think about it this way. If a cheetah can maintain a constant speed of 25 meters per second, it'll cover 25 meters every second. At this rate, how far do you think it'll travel in, like 10 seconds? Or even in a minute? So let's think about that one for a minute. So, Trixie, you know when I throw the ball? Yeah, and I tell you to go get it? Well, I'm trying to see how fast an object is moving. Hey, you're not paying attention. And so that's speed. Speed is how fast something's moving. And you calculate the speed of an object by dividing the distance covered by the time. So if we go back to our cheetah problem, remember? If a cheetah covers 50 meters in a time of 2 seconds, its speed is 25 meters per second. Did you know that any combination of units for distance and time that are useful and convenient are legitimate for describing speed? Oh yeah, there's all kinds. You can say miles per hour, you can say kilometers per hour, we can say meters per second, you can say light years per century. And did you know that the speed at any instant is called instantaneous speed? So for example, if you're in a car and it's traveling at 50 kilometers per hour, it may go that speed for only 1 minute. But then you kind of put on the accelerator, you're going a little faster. Sometimes you put on the brake, you're going a little slower. So that instantaneous speed is what you're doing in that 1 instant. Where the average speed is the total distance covered divided by the total time. It does not indicate variations in the speed that may take place during the trip. So if we know average speed and travel time, the distance traveled is easy to find by rearranging the original formula. So the total distance covered equals the average speed times the travel time. For example, let's say that you're chasing after a kitty cat and you're running 80 kilometers per hour. Well, and you're on a 4-hour trip. Well, then you cover a total distance of 320 kilometers. So remember that cheetah problem that I told you about? So if a cheetah can maintain a constant speed of 25 meters per second, it'll cover 25 meters every second. At this rate, how far will it travel in 10 seconds? In 10 seconds, the cheetah will cover 250 meters, and in 1 minute, it'll cover 1,500 meters. Here's the thing, speed and velocity, they're interchangeable. So cars' speed gauge is a speedometer. It's not a velocimeter, because the speedometer of a car measures the speed at any instant, but not its direction. And velocity is a vector quantity because it has both magnitude and direction. So constant speed means that it's a steady speed. And constant velocity means both constant speed and constant direction. So constant velocity means motion in a straight line at a constant speed. But sometimes you have changing velocity. So constant speed and constant velocity, they're not the same. So if either the speed or the direction or both is changing, then the velocity is changing. So in a car, there are 3 controls that are used to change the velocity. The gas pedal, it's used to maintain or increase the speed. The brake, It's used to decrease the speed. And the steering wheel, that's used to change the direction. So here's what I want you to think about. So let's say you're in an airplane and it travels about 500 kilometers due north in about 1 hour. So what's its velocity if it travels 250 kilometers due north in a half hour? Or how about 125 kilometers north in a quarter hour? Well, if you work it out, each answer is the same. It's 500 kilometers per hour north. When we talk about velocity, we also have to kind of mention acceleration. Acceleration is the rate at which velocity is changing. You can calculate the acceleration of an object by dividing the change in its velocity by the time. And we can change the state of motion of an object by changing its speed, its direction of motion, or both. And any of these changes is a change in velocity. So like passing a driver on a 2-lane road, or if you're chasing another puppy and you pass them off, then you're accelerating them. See, the key that describes acceleration is change. And whenever we change our state of motion, we're accelerating. Having good acceleration means being able to change velocity quickly and does not necessarily refer to how fast something's moving. In physics, the term acceleration applies to decreases as well as increases in speeds. The brakes of a car can produce large retarding accelerations. What that means is that they can produce a large decrease per second in speed, which we refer to as deceleration. So people think that acceleration is simply an increase in speed, but you know what? The fact is acceleration is any change in speed, direction, or both, which means it must be a vector quantity. So if you ride around a curve at a constant speed of 50 kilometers per hour, you feel the effects of acceleration as your body tends to move forward the outside of the curve. You may round the curve at a constant speed, but your velocity is not constant because your direction is changing. When straight line motion is considered, it is common to use speed and velocity interchangeable. When the direction is not changing, the acceleration may be expressed as the rate at which speed changes. Okay, an acceleration along a straight line equals the change in speed divided by the time interval. Let's try one last problem and then I'll let you go chase the cat. In 5 seconds, a car moving in a straight line increases its speed from 50 kilometers per hour to 65 kilometers per hour, while a truck goes from rest to 15 kilometers per hour in a straight line. Which undergoes the greater acceleration? In 5 seconds, a car moving in a straight line increases in its speed from 50 kilometers per hour to 65 kilometers per hour, while a truck goes from rest to 15 kilometers per hour in a straight line. So Trixie, which one undergoes a greater acceleration? And what's the acceleration of each vehicle? Well, here's the answer. The car and the truck both increase their speed by 15 kilometers per hour during the same time interval. So guess what? Their acceleration's the same. Isn't that cool? Okay, well, pretty much that's all I have. So why don't you go chase the cat? Uh-oh, what is he doing? Kitty!